Gomamela. The gomamela belongs to radial symmetry. Radial symmetry means a shape can be divided into equal parts from the center like a circle. It belongs to radial symmetry because its 5 petals are arranged evenly around the center. If you draw a line through the middle, both sides look balanced. This symmetry helps attract pollinators since the flower look proportioned and complete from any angle. Raindrops. A raindrop belongs to wave pattern. A wave pattern is a repeated movement that spreads energy from one place to another. It often looks like ripples or lines moving outward. Raindrops belongs to wave pattern because when they fall into water, they make ripples. The drop gives its energy to the water and the water moves in circles. Wasp. The wasp shows a clear pattern of stripes on its body. Stripes are lines of color that repeat in a regular way. On the wasp, the yellow and black stripes go across its body and create a strong contrast. This repeating pattern is called a stripe pattern. In nature, stripes often help with the protection and warning, and they make the animal easy to recognize. Oak leaf. The oak leaf shows a fractal pattern. A fractal pattern is a design that repeats itself in smaller and smaller parts. In nature, fractals are common in trees, leaves, and branches. This repeating structure helps transport water and nutrients throughout the leaf.
Pineapple. The pattern of a pineapple is a spiral. If you look closely at a pineapple, you will see small diamond shapes arranged in spirals going upward and downward. These spirals form a repeating and organized design on the fruit surface. A pineapple follows the Fibonacci sequence because the number of spirals on its surface is usually 8, 13, or 21. This pattern helps the fruit grow and pack its sections efficiently. This plant is cauliflower. Cauliflower has a fractal pattern because its small flowers like a tiny copies of the whole head. The same shape repeats over and over at different sizes. Pine cone. The scales of a pine cone are arranged in spirals that go in opposite directions. This spiral design helps the scales fit closely together in an organized way. A pine cone follows the Fibonacci sequence because its spirals usually number 8 and 13. This helps it grow in an organized and efficient way. Snail. Snail shells form a logarithmic spiral where the shell grows outward but maintains the same shape as it enlarges. Snails follows the Fibonacci sequence. The number of thorns in the spiral or the ratio of a growth in some snail shells approximates the golden ratio, which is closely related to Fibonacci numbers. Tree crack. The pattern of a tree crack is a fracture. Tree crack form when the wood expands and contracts due to changes in moisture, temperature, or age. These cracks usually branch irregularly and split the surface into jagged and even segments. Bubbles. Bubbles group together in clusters, forming a foam-like structures where each bubble fits closely with its neighbors. This creates repeating shapes, usually hexagons, to use space efficiently.